Welcome to the Miss Mountain.
Hey guys, welcome back.
Let's continue and finish up our okay? Oh, sorry, I thought it was yesterday.
I think the camera is on.
But yesterday is supposed to be updated by the but you all haven't seen the time now.
Thanks. Eating wasn't the word I used, but okay. Bro, it doesn't matter. It doesn't matter.
So yesterday we started with differentiating your exponential functions, and we learned that it is fairly straightforward in comparison to all the other things that we have learned so far. Okay. So if I want to differentiate our exponential function, we know that we'll get back the same thing. Likewise, if I want to differentiate, let's say our power itself is another function, what we will get is the derivative of that function multiplying with the exponential. Okay. And then something very important that we reinforced yesterday also, avoid any confusion. If let's say we are differentiating e to the power of a number, let's say maybe 3, we must be clear that it is equals to 0 because it is a constant number. Okay, so these are the very key things that we covered yesterday. Today we're going to be looking at the application part about all this differentiation. Okay, so we look at try 7 first. Okay, just to warm up our brains, could you please differentiate, okay, the given function y equals to x e to the power of x minus 1. Find out what is the first derivative and the second derivative. I'll give you about 5 minutes to work on that. Okay. In few 4 minutes, hope that you're able to get these derivatives. Okay. So we apply our product rule, keeping x itself differentiate e to the power x minus 1. Don't forget that we need to differentiate x minus 1, so coincidentally that is equals to 1. Okay. Then after that we keep the right side differentiating x, we'll get 1. Okay. Then after that we simplify it, right, such that we get e to the power x minus 1 times x plus 1. Although the question did not ask for it to be factorized, okay, you will find that it is easier to manage if you factorize and then you find the second derivative. Okay? Because when you factorize it at this stage already, then you find your second derivative, you will keep left, differentiate right, keep right, differentiate left. Okay, apply your product rule. Unlike if you were to do it from dy over dx, based on this, right? Okay, then you have to apply product rule over here and then do your usual differentiation over here. So you can get slightly lengthier. Okay, so therefore factorizing it here will actually be easier, so that when you differentiate, it will be neater lah. Okay. Then we also try to factorize our answer all the way to 10 here. Okay. Questions? Right. This is what happened to your specs. Then you can see it.
Okay, doesn't give me wait, you see the first one.
Okay, I guess that works. I guess that's what friends are for. But your degrees are the same, man.
Is it because?
Okay. I shall not judge. Okay. Alright, part 2.
I know you're
okay. Part 2 itself, we want to find the coordinates of the stationary point of the curve and determine its nature. So stationary point, we know that dy over dx must be equals to 0. So we will do that where we let e to the power x minus 1 times x plus 1 equals to 0. Okay? Then we go about solving, so that is your zero product rule. So these are two things multiplying. It will mean that this thing must be equals to 0, or else x plus 1 equals to 0. Okay? So this brings us back to remembering our logarithms solving. Okay? So our x is in the power. How do we go about solving it? Okay? If you recall from your logarithm, we can apply ln on both sides. Why do I apply ln, the natural logarithm? Because this is e. Okay, so applying ln on both sides, that will mean that your power over here can come down. That is your logarithm rule. Okay, and we arrive at this. And then ln e itself, okay, will actually be 1. Okay. But if you were to press your calculator for ln 0, what will you get? A math error. Okay? And that is because exponential itself, or any number, let's say 2 to the power of something that we do not know, is it ever possible to have 0? We will never have a 0. Okay? Because regardless of whatever number you have over here, no matter what, you will never be able to get 0. Even 0 itself, to the power of 0 is supposed to be 1. Okay? So exponential to the power of anything can never be 0. Okay? Right? So therefore, I'm just showing you, okay, how you would probably routinely go and do by logarithms. I want you to realize that non-zero is not possible because it's not defined. So actually, this one you reject. Okay? So depending on which level you realize it, okay, you must know that at the end of the day, this one is not solvable. Okay, you have to reject it. It doesn't provide us with any solution. Okay? Then x plus 1 equals to 0 itself. This one can solve. We get x equals to -1. Okay? So we get the x coordinate of one stationary point, that is -1. Okay? And then we need to find the y coordinate. So when x equals to -1, y will be equals to -1 times e to the power -1 minus 1. And we get -e to the power of -2. Depending on the question, sometimes they may ask for exact coordinates. So if exact, then you leave it in e and your coordinates will be -1, negative e to the power -2. Okay? Then the question asks to determine its nature. So we will need the second derivative in order to do the second derivative test. So x is -1, substitute inside here. Could just use your calculator, okay, to determine what is the value. You would get about 0.13533, and that is positive. Therefore, your stationary point is actually a minimum point. Okay. Any questions? Since we are at solving exponential functions and also on stationary points, let's go to exercise 15.2, question 16 first. Alright, let's take a look at exercise 15.2, question 16. In this question, because it comes from the textbook, they actually gave a hint that you're supposed to use logarithms. Okay, when it comes to your tests and exams, surely they will not tell you to use logarithms. Okay, you're expected to know that in order to solve e to the power of 2 minus 3x equals to 3e to the power of negative 2x, you need to use logarithms. So how to use logarithms? Because our base is e, we should use the natural log. So we apply ln on both sides. Okay. So when we so-called apply ln on both sides, we're doing it for the entire function for each side. Okay. So therefore I put brackets around the function. Right? Then now, okay, trying to push us to recall our logarithm rules. Let me just do a quick check whether I put it inside here. I remember I did. Okay, yes. So if you look at your little notebook, right? Okay, on page 3 logarithms, there are all your logarithm laws over there, just to help you to recall. Okay. So in order to solve this one, okay, on the left side, this is to the power, okay, so therefore we can bring it down using our ln number a. Okay, so we will get 2 minus 3 in its entirety, okay, ln e. Okay. Whereas for this one on the right, I want us to be careful to realize that the power negative 2x only belongs to the e, it doesn't belong to the 3. So therefore I cannot bring this negative 2x down, okay, because I can only bring down the power if that power itself is for everything, okay, that is in that function. So what do I have to do with this? In this case, you can break it up using your law number b, okay, so because they are multiplying, so ln 3 plus ln e to the power of negative 2. 2x. Okay? So remember, when it is a product within inside the logarithm, you can split them up open and change it into a plus. Okay? Then ln E itself, if you press your calculator, you will realize it is a 1. Okay, so therefore on the left side is just 2 minus 3x. Our question wants us to find out the exact root. Therefore, don't press your calculator for ln 3. Whereas for this one, the power itself is for E already. You can bring down that power. So ln E again, it is 1. So therefore, we will get minus 2x over here. Okay. We're trying to find the root. The root refers to finding the value of x. So we need to find the value of x. Just shift around in this equation. And we find that x is equals to 2 minus ln 3. And that will be the exact root. Okay. Questions? Okay. So you notice that along the way this year, there's really a lot of last year's topics being peppered along the way, okay, into the questions. Right? So in this case, I'm trying to bring back our logarithm rules, okay, because later on we have go into 15.3, which is on derivatives of your logarithm functions. All your logarithm laws will need to come back. Okay. Then looking at part 2. Okay, there are a few ways that we can do part 2. The question wants us to show that this function has a stationary point at a particular point. Okay, so 2 ways that you can do it. Either you find dy over dx first, take this point, put it inside the dy over dx, show that dy over dx ends up becoming 0, then it is a stationary point. So that's one way. That means you take the point, show stationary point, which is dy over dx equals to 0. Okay. The other way is that you know that stationary point must be dy over dx equals to 0. Then from here, you try to find the point itself. Okay, so there are 2 ways to get around this because the information is really provided. Okay, unlike if they ask you to maybe find the stationary point. Okay, find the stationary point, then you can only go in this direction really. Okay, so let's work on one of the direction first. So given y equals e to the power of 2 minus 3x minus 3e to the power of negative 2x, we differentiate. So differentiating this, you will get the same thing, then not forgetting to multiply by negative 3, minus away, same thing again, differentiating the power, you get negative 2. Okay, and then we arrive at this. In this case, there's nothing for us to really factorize since the factors are not clear. You can maybe consider factorizing 3, but it isn't that much meaningful. Okay? So from here, my first method was to use the point that's given to show dy over dx will be equals to 0 because that is what stationary point implies. Okay, so that's one of the methods going from bottom up. Okay, So in this particular case, our x value, x coordinate is 2 minus ln 2. We will substitute inside here. Okay, so changing all the x, you will get this. While it may sound easy to prove that it is equals to 0, okay, let me think for a moment. Because the question says show can you try for me? Sorry, I never tried this before. Can you try for me whether this can be pressed into your calculator? Can you get 0? You nod your head, you go try already. Oh. Can you, other people, can you try? Okay. I trust you lah, I trust you. Okay. Can you press your calculator and get 0? You look at me like I'm the calculator. Press okay. Okay. It's a little unconventional question. Okay. I only just realized that yes, maybe you can press calculator and get 0, but I want us to practice our manipulation. Okay. Since this is also a show question. Okay. So if I want to simplify this, 2 minus 3 times 2 minus ln 2, I will expand it. 3 times 2 and then 3 times ln 2. Okay, we will get this. I know press calculator is an easy way to go lah, okay? But because the question says show, alright? And then I think we should also practice learning how to manipulate things, okay? Actually, I don't know. Yeah, because in the first place, right? Okay, in the first place, I've never seen an exam question like that. Yeah, okay. I mean, that's a problem about textbook questions. Okay, textbook questions, they expect certain things for you to practice. That's the whole purpose of textbook questions, right? For you to practice. Okay, that's why I want us to go through the rigor itself. Okay, but then when it comes to exam question, if you ask me, in my experience, okay, I wouldn't have done something like that. I would just say find the stationary point. Yeah. Okay, find the stationary point, then yeah, you would then have to go through all this tedious process. Okay, so let me just finish this up. Okay. Okay, let me explain and run through it now. Okay. So we substitute in already. Yes, the easy way out is to press calculator, no doubt. Okay. You can press this in your calculator, you can get 0. And then that's done already. Okay. However, in this particular question, what if we need to go about manipulating? Okay, so what I would have done is to expand this. So 3 expand into 2 and ln 2, you get minus 6 plus 3 ln 2. Likewise over here, expand again, we will get the power to be negative 4 plus 2 ln 2. Okay, then after you simplify the power, you'll get 2 minus 6 negative 4 plus 3 ln 2 over here. This one already simplified. Then, okay, because we're trying to go towards hitting 0, we need to simplify it. Okay, so therefore, because I don't like to deal with negative powers, over here the power has negative 4 and negative 4. Pay attention. Okay, and then after that we can bring it and re-express it such that the e to the power of negative 4 can be placed into the denominator. Okay, then I go about factorizing out 3 and e to the power of 4 from both terms. Therefore, I get this expression. And then after I simplify the things in the brackets, I'll get negative e to the power of 3 ln 2 plus 2e to the power of 2 ln 2. Okay? And then over here, sorry, my brackets is wrong. Okay? So, this is e to the power of 3 ln 2, which essentially means 3 times ln 2. Using your indices law, it is as good as saying e to the power of ln 2 bracket to the power of 3. Likewise over here, e to the power of 2 ln 2 is the same as e to the power of ln 2 bracket to the power of 2. Okay? Then I see that there is a common factor of e ln 2. I can take that out. Okay? Then I'll be left with a single negative e ln 2 and then also a plus 2 over here. E to the power of ln 2 is actually 2 itself. Okay, negative 2 in the end because the negative sign here, and this is clearly equals to 0, therefore it becomes 0 itself. Okay, I just want to run us through the whole simplification process. I leave it up to you, okay, whether you want to copy and all that. Because I do agree with you that you can press into calculator for this question. Okay, it's really more for us to practice, okay, how to go about doing this. Okay. Yeah. Now the one here, go to here. So e to the power negative 4 plus 3 ln 2, we know that is e to the power negative 4 times e to the power 3 ln 2. E to the power negative 4 is the same as being in the denominator e to the power 4. Okay?
You see that last two steps? E power 4 is
Okay.
initially the last.
What if, for example, okay, the question wants you to find the point. Okay, maybe this will be more useful for us to think about.
So it becomes E ln 4, right?
Which is to find the stationary point. Then we will have to make use of your dy over dx to be equals to 0. Okay, and express it this way. And then we have to go in search of the x itself. Okay, now the thing is, how do we go in search of the x? Because if I want to, let's say, it's exponential, we use logarithm. If you were to use logarithm and apply it on both sides, okay, this will be what you get, and then it's actually not something solvable. Because we know that ln 0 is undefined. Okay? How we can get around things is that we can bring this one exponential to the other side so that we have 6e to the power negative 2x equals to 3e to the power 2 minus 3x. Okay? Then from here, okay, we can simplify first before trying to apply our logarithms. So you can divide by 3.
Oh.
And then we arrive at this. Okay? Then now we go about applying logarithm on both sides. and then we apply our logarithm laws. Okay, then the power is being brought down, and we know that ln E is 1. So ln 2 minus 2x equals 2 minus 3x. Ln 2 is in itself, there's no brackets around here. And we solve that E is equals to 2 minus ln 2. Okay? So in your very typical question, most likely you will be asked to find the stationary point instead. Okay, and then you cannot avoid this tedious process anymore. Okay? So after getting x equals to 2 minus ln 2, because the question wants us to show that this is the stationary point, we still need the y coordinate. So we need to go and find the y coordinate. Okay. So substituting the x coordinate, we'll get this. The question wants you to find the exact value. Okay, so this one there's no way for you to press calculator. Because you press calculator, you will get a decimal value. And it's not exact at all. Okay, so we can't run away from this process. Okay. So again, I expand it. Okay, so for expansion, our power itself will be e to the power negative 4 plus 3 ln 2 minus 3e to the power negative 4 plus 2 ln 2. Okay, and maybe just to be very clear, because I know that some of you are not that strong with the indices. Okay, this is what it breaks up to become. I want us to know that e and logarithm or natural log, they are actually inverse functions of each other, so they do cancel each other out. Okay, so if you had observed earlier, you may have seen a little bit of steps. So e and ln do cancel each other out such that we get it itself. If you don't know that, you can always press calculator for this number here. Okay, likewise, you can also press calculator for this number here. Okay, because e to the power ln 4 does give you 4 such that it becomes a 12. Okay, and then 8 minus 12, 8 over e to the power 4 minus 12 over e to the power 4 is the same as 8 minus 12 over e to the power 4, since the denominator is the same. Okay. and that would give us negative 4 e to the power of negative 4. Okay. So this would be like a process that you will go through, okay, in your typical exam setting, where they don't give you the point itself. Okay, so still cannot run away from the whole simplification process if you're always in search of the exact answer. Okay. Any questions? Oh, you raised the purple one. Questions? Okay, we do one final one, then we call it a day. Let's look at exercise 15.2, question 9. Just to revisit our connected rates of change. Okay, could I erase the previous answer? And okay, looking at exercise 15.2, question 9, the first part will be fairly straightforward because it is just giving you a function and then after that we find our dy over dx. Okay, but although it is straightforward, I don't want us to make it complicated for ourselves. I hope that we are able to realize that y equals to e to the power negative 2x over 6 is the same as 1 over 6 times e to the power negative 2x. So that our dy over dx, okay, will be to keep the same thing followed by the differentiation of the power. Okay, please don't do any quotient rule or product rule. That's not very efficient. Okay, so we get negative 1/3 e to the power negative 2x. Okay. Then in part 2, it says hence find the rate of change of y. That means that we are trying to find out what is dy over dt. And given that x is increasing at a certain rate, which is p units per second, when given this condition. So that means that when x equals to 1, we know that dx over dt is given to be p units per second. Okay? So question wants us to find out what is dy over dt. We already have our dy over dx. Okay, so in order to find out what is dy over dt, it will be equals to dy over dx times dx over dt. Okay, so that will be our connected rate of change formula. Okay, and then dy over dx will be negative 1/3 e to the power negative 2x, while dx over dt is actually p, and that is when x is equals to 1, so we can change this x over here to 1. Okay. And hence our dy over dt will be equals to negative 1/3 e to the power negative 2 times p. And so in this particular case, your y is decreasing. Or if you want to state, you can say the rate of change of y okay. So if you don't want to talk about whether is it increasing or decreasing or not, since the question did not ask for it, you could just say that the rate of change is this value here, units per second. Alternative way of writing this, you can write it as p over 3e squared. Take note that p is a number, a constant value, just that they don't give you the number, they use a letter to represent. Okay? Right? Questions? Okay. For homework, your 15.2, where should I write it? I'll write it here. Okay, just question 6a, 13, 14, and 15. Could we have it due on Friday? No. Okay, I see the jaw drop. Okay. Due on Monday, then yeah. After this week, how many of you still have CCA? Okay. I mean the performing arts still have SY going on. And the rest all stepped down already? Okay, no, not yet. That one, yeah. EB. See? Huh? 1/5? Oh! What 1/5? Is that like a new hip-hop group? Okay. Still got 10 minutes if you start working on your homework. Okay. Tomorrow then we go into logarithms. Okay, I think you need to have the time to sink these concepts into your minds. Just to ensure, please raise your hand as they come to you.
Oh wait, thanks for watching guys. Remember to hit that like button and subscribe.
Okay, by the way, at this rate, right, your matrices, please get it done by end of this week. Okay, I know most of you have done it already. Okay, so please get it done by Friday because next Monday they will start from the matrices itself. Okay. Do I finish the matrices?
Thanks for watching.
Like, comment, and subscribe.
Yes.